All right, on today's episode of Python Papi, we're back inside our TensorFlow course, and we're still doing our malaria confusion matrix module. Let's have a look at what we went over today. But first, we're going to go back and revisit the malaria precision recall accuracy module to look at the information that we ran overnight. Now, for some reason, I never had this before. It was so much information that it's actually not loading all of the information to my terminal. Well, it loaded all of the information. I saw all of the information as it came through the terminal as it compiled, but for some reason it's not recalling all of it. It's not pulling all of it up. So you can see here, we just have this here is going to be a history, but we did the model. The model ran. I watched the model compile and run and everything. Everything came through well. And the history, you can see here that the history is actually starting from 2171 of 2757, even though I watched it start from zero. So I don't. It's the first time I've seen this. It's cutting off the previous information that came before because it's not fitting into the terminal. But whatever the case may be, we actually did see it running and compile and everything came through. So this is what we have here. Like I said, the history. This is the history here. You see running through it. Maybe because our test data set is so large. You can see here we ran through 2,700 or 2,757 pieces of information, and we actually gone ahead. We did the Lynette custom model to evaluate. We evaluated our test data set. Let me show you that really quickly. So after all of that ran, we did have our test data set evaluation, and that's this last one here. You can see it was 348 seconds, 117 milliseconds per step. We have a loss of 0.0013. Here's our true positive, our false positive of 2. True negative is 2,755. False negative 0. Then we have our binary accuracy, which is a 0.9993. Then we have our precision, which is 0. Recall is 0. And the area under what was the A? What was AUC? The area under what is the AUC again? I'm sorry, I'm drawing a blank. I can't remember what the AUC stood for. Let me actually find that. It would be best to know what those terms mean that we're going to be using. All right. So we have the. Let me get and find it in my notes here really quickly. Sorry about the area under curve. Okay, so yeah, the AUC is going to be 0, and that's the area under curve. So like I said, everything did compile and run successfully, but for some reason, it's not loading all the information back into the terminal that it ran through. Like I said, I watched it compile. Everything did come through successfully, but for some reason, it's not recalling all of it. I guess because it's such a big model. I'm not sure. I've never seen it happen before. So yeah, that's that. But we did move on to malaria confusion, and that's this one here. We did do some note taking, and we did start some modeling on this actual module that we're going to run tomorrow. So let's do some light reading on that really quickly and show you where we are. So in this section, we will be going over the confusion matrix in more detail. Up until now, we have been using everything from the binary accuracy up until the area under the curve. Now, what if we plotted out the confusion matrix and also the ROC plot? To actually handle this process, we will import over scikit-learn and Seaborn, see lines 10 and 12. That's what we imported it. I can show you really quickly, I guess. You can see here 10 scikit-learn, 12 is Seaborn, that's S and S. And then we also have the scikit metrics. We're going to import the confusion matrix. So that's how we did that. Let's go back down and finish our reading. And then to actually handle this process, we import over. So, okay, I did that part already. Also from scikit-learn, we did that part already. I showed you confusion matrix, C line 11. Now these imports are going to allow us to plot out our confusion matrix. So we'll run this and visualize our confusion matrix. We have to get, let me close this gap here. We have to get the labels, and that's the true values of the outputs. And then we'll go ahead and get the predicted values. So we have our labels and predicted values. Let's start with the labels. Here we're going to have labels, and for now we're going to assign them to an empty list. Let me show you what that looks like here. You can see this is our labels, and it's assigned to an empty list. So that's what we have so far. We're just starting with the labels. We're not working on the predicted values just yet. So and then for X and Y in the test data set, and we're also going to attach a. We're also going to attach and dot as numpy iterator to our test data set. So for X and Y, we have X and Y. From here, we will append every output to these labels. So we'll have labels that append Y, and then we can run this. Now we can print out our labels. After printing out our labels, we'll see that we have our labels for the outputs. Now let's convert them into a simpler form where we only have the values of the outputs returned and not the arrays. No, just keep in mind, I haven't done any of this yet. I'm just getting it queued up for when we do run it. I'm explaining everything now. So in order to perform this task, we will have the labels equal to the numpy.array or np.array, a list. And inside the np.array, we are going to create a list. In this list, for every element of this label list, we're going to the 0th index. So we're always going to take the element in the array, or not the array, and not the array. We just want the element and not the array. We want to isolate just the elements. We want to return just the elements without the array. So now we will print out the labels again after doing the transformation. So this is what we have so far. We have our labels. We have 4x, y, and test data set dot as numpy iterator. Labels dot append. This is going to bring back all of our outputs, and this is going to print all of our labels with the outputs. And this part right here is the actual part that's going to bring back just the outputs without the array. But I left this blank for now. I commented this out for now because I'm going to run a regular first and bring back the labels so I can see how everything works normally before we transform it and bring back just the values and not the array. So yeah, I will be doing that overnight, and of course we will pick it up tomorrow. And of course I will keep you guys posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.